Okay, so one of the important elements of the way I like to teach is the use of the blackboard. And this is actually a picture of the blackboard at the end of one of the classes of the tic-tac-toe activity. The last time I taught it in class. And you can see a bunch of things here. I apologize for the blurry image. I have more detailed images that we'll get to in a moment. But this is what I end up doing in most classes. I end up using the Blackboard quite a bit. And there are things that get recorded in the lecture off of the screen, but this part remains unrecorded because there is no camera pointing at the blackboard. So what I want to do is I'm going to, wherever I'm talking about the blackboard in the lectures, I'm going to pick those points and talk you through what exactly I'm talking about so you don't miss out on anything. So this is where at first you'll see we're talking a bit about model view controller right here, where it says MVC. And then we were developing the list, the table that displays the games. And over here on the right, we are developing the game model. So this is what the list that we are creating, it looks like. In Android, we are going to be building an adapter. In iOS, we work with the table view controller, and from the controller, we import, we read all the data and display it. And we design a prototype cell in both Android and iOS. It's the same process. And what happens is that we end up with a model view controller kind of design where the view displays what is there. The model stores the data that is to be displayed, but they don't talk to each other. All the communication happens through the controller. Controller gets the data from the model and displays it in the view. If there is any interaction on the view, the user performs a touch or anything, that information the controller takes and passes it on to the model in case any update is needed. So this is the model view control part. The next thing I want to talk about is the model itself for the tic-tac-toe game. Now, typically I would start off by drawing a blank grid. Imagine a blank grid here without any of these numbers, etc. And then we'll work on it. We'll talk about things like what does the model need? What do we need to store? And then somebody would typically answer that we need to know what are the moves that are being played. And then we decide how to store them. And the options given were a 2D array. You could store it as a two-dimensional array, which column, which row, etc. Or we could go with a one-dimensional array. So in this case, we prefer to go with a one-dimensional array, and instead of having two directions, X and Y, let's say, we just number each cell 1, 2, 3, 4, 5, 6, 7, 8, 9, like so, and store what is there in each one of those cells. So for example, if X plays first and goes on the 5, then we will know that the fifth cell, the fifth element, element number 5 in the array has an X in it. The remaining would still be blank. Like this, we store. So that is what we would call moves played, which moves have been played. And then I would keep on asking, what else do we need to store? And then somebody would come up with whose turn it is. So if we don't know whose turn it is and there is a touch, we won't know whether to place an X or an O there. So we decide that, we decide that we need to know whose turn it is. So this will be either X or O. And if it is X's turn, then when a touch occurs, we place an X in it, record the move in this moves played array, one-dimensional array. And then we also say, okay, what else do we need to know about this game? So then we come up with that, okay, we need to know if the game is finished. So then the question comes, okay, how do we know that the game is finished? The game is finished when there are three of a kind, either O's or X's, in a row, in a column, or in a diagonal. That's when one of them, either X or the O, has won the game. But then the question comes, are there any other possibilities? And the answer is yes. The match can end in a draw. Nobody can win. And if you play this game logically, two people who are, very good at playing, they will always end in a draw. They will not let the other person win. So that's our third possibility. X can win, O can win, or it can end in a draw. And whenever that has happened, we know that the game is finished. So our model for the tic-tac-toe game itself needs to know these things. These are the variables we have identified. What moves have been played, whose turn it is, and whether the game is finished. And if one of them wins the game before the last move, then no more moves can be accepted, even though there may be blank squares. That's why we need to know that the game is finished and stop accepting new touches. This will give us a model. Then typically I would ask the question, all right, do we need to determine all the time whether there is a row or a column, 3 in a row somewhere, 3 in a sequence? Or can we determine that in advance? Do we know which combinations lead to those winning scenarios? And once again, the answer comes back as yes. It's basically, if you count, there are 3 possible ways horizontally that somebody could win, 3 vertically, and 2 diagonally. So that gives us 8 total combinations, 8 total possibilities for winning. And each one of them is known to us beforehand. For example, if the 3 in a sequence appear in the first row, it's 1, 2, and 3. So we create now an array with winning combinations. And this can be a two-dimensional array, depending upon how we want to store it. And here we store the combination. So the first one here is 1, 2, 3. The second one is 4, 5, 6, the middle horizontal row, and then this one. And like this, we have got all 8 of them, including the 2 diagonals in the end, 1, 5, 9, and 3, 5, 7. So these are the winning combinations that could happen through which a game can end with either X or O winning. And once we have this much information with us, then we can start building the model, which is what we will do in both the apps, iOS and Android.